Welcome back, guys. Continuing on MVVM using Swift, we have already tried out some of the flavors of a little bit of RX Swift, and then we had Realm, a little bit of that, all combined together. We created an application, to-do application. So let's try out a little bit of networking right now, where we'll be using a framework called Alamofire. So as such, we are in a state where we can load the data locally, but when let's say we have something coming from the server side, then how will we handle it? So that's the topic of interest today, where I'll be using a framework called Alamofire, which is available as AF networking in Objective-C. The similar, so it's a similar framework, or it's being done by the same team which has created this Alamofire. So to include that, all you need to do is pick up the latest version, go to your pod file, include it, and open it in CocoaPods. You can see that it's included, and then just install it. Because it's already installed, it took it from the cache. So Alamofire is included now in the project. You can see it within the pods folder, and all you have to do is do a clean build, and then let's open and close once. Clean is done. So by the time it compiles, Alamofire supports many of the features like retry policy, large image download, large file download, upload, etc. And usage is pretty easy. Also, it has some integration with other libraries like Alamofire image. If you're using, then it can do image caching and even cropping, etc., different other features. And there are even, it has support with RX Swift. So if you're using the RX community, they have a library where you can include RX features to handle the responses from if you're making a request. So those are some of the interesting things which we can have a look at later tutorials, but this is something I prefer to use in my projects. So by the time it compiles, so we are at a state where right now in the project calls are being delegated to the view model. So on load we have right now nothing loaded, but then we are adding it. So we have an insert add to do item, which is making a database call and adding that item. So what we will do right now is include an API call. So for that I already have a local server running using PHP, so our build is ready. So I'm using a PHP Laravel API to just have some data loaded on an API call, which will happen when we do something like as it is local, I have it routed through the to-dos. So this is what we will be including as an API call to get these to-do items from the server. So this is a local server and we are using the local API to fetch those data. So our Alamofire is included now. So let's, as a next step, let's create an API service, because it's always good to keep our modules separate. That's my API service. Maybe I can have a protocol defined to have the functions exposed. So currently maybe I can call it API service protocol, which right now I might have a function called fetch all, which is like the fetch all to do items, fetch all to dos, and let me also have a completion block, which is nothing but a closure which will respond back with the data received. So that's my closure, some completion. So let me just type alias. Associated type, response data. So let me include that as the type, and then if I implement API service protocol, I need to include the type alias, which in this case is the data type. I don't always prefer to import things which are not required. Sometimes you might end up having so many imports within your protocol, which is not so great. You always keep it lean with a type. It can either be generic or it can be a base type. So that being done, let me just call the function fetch all to dos, and then the type is now data, so that as we defined the type alias, it replaced it with that type. So now to make an Alamofire call, you need to import the library Alamofire, and to make a request, it is as simple as Alamofire dot, let's go to the documentation. So a simple request, let's say if you're making a get request, so all you need to do is let's making a request. So you just need to call alamofire.request, and it will require a URL. So my URL is string type, let me just pick up that particular URL. So I'm just fetching the URLs. So Alamofire supports something called as routing. So using that, you can create or URL convertibles, which will allow you to make your URL request type safe. So that is something we can look at later, which is an interesting concept. We're just passing the URL, and then still it is compiling. Okay, Okay, so that's an optional. You can cast it, and the response we'll be receiving it as my API is the response type for that is JSON. So all I need to do is to receive the response. So let's do a basic print to see what happens now. So I have the response now. So normally the response will be received through the data. We even print some of the other things like response dot request. What is the request that went through? Response dot request dot then response dot status code. So there are different options available through this response. So let's do a basic print and see what happens. So before that, we have the API service. Let's make it a singleton. Share instance of API service. And have a private in it. Dependencies, I don't have any as yet, so I'm just keeping it blank, making it private so that nobody can instantiate outside of this class. So that's my instance. I'll be accessing this fetch all to do through the shared instance. Let's go to the view model. So in the view model, I will be loading this. Let's go to my 2D view model. So this is my init. On init, I'll be loading it when the app is launching. So let me make a database call now. So even before I make the database call, let me just create singleton call. So mine is an API service dot shared instance start fetch all to-dos, and my closure returns the data object. So it's even better to print it here and then remove that print there. Let's print the data here. So I have a request and response here, and on the completion it's accepting a data object. So that's this response data. So let's try and see now, because closure. Okay, so we need to make it escaping. That's nothing but this cannot escape the return type. So if you have the function returning, even then you can use this protocol, this closure. So that being escaping now. So that being done, let's go back, run the app and see. Before that, let me just delete the earlier application. Let's throw the hardware, go home, delete. So the application is now a clean slate. We now have to include the to-do items through the network. So that's through the API. So We made a request and there was no response. Let's go back and see what went wrong. Okay, so we have an exception because of app transport security has been blocked for HTTP resource load since it is insecure. So to avoid that, I can hack it right now by including NS app security, transport security within my info.plist. Go here, add that. It will be of type dictionary. Go inside, add one more called allow arbitrary loads. Set it to true. Yes. So this should fix that issue. Let's see. Yeah, so we have prints optional 200. That's the first response. So let's go back to our API service. That's the status code 200. That was fine. Request sent was this, and we received an 184 bytes data. So this data has come back as JSON. So what we need to do as a next step is to parse that. Let's go back to the place where we received the response. So we have it here in the print, and as a next step, let's deserialize this data. So for that, I have the code, a little bit of code snippet. We will do the traditional way first, where we will use the JSON serialization provided by Swift as an iOS framework. That's a little tedious. After that, we will have a look at how to use something called a library called SwiftyJSON, which makes it pretty easy to deserialize your JSON and then convert it into a Swift object. So let's first do the traditional way, where we'll be using the JSON serialization, deserialization using regular way, where it will accept the data. That's my response data, and it will convert it into JSON data, or maybe the dictionary object. So the first object, that if you look at the structure, it is a dictionary. This object is a dictionary, and you can access an array through the to-dos key value. So that's a first step. So we have a dictionary, we can access an array through that dictionary using the to-dos key, and within that array you have a collection of dictionaries. If you see, these are different collection of dictionaries. So we have to deserialize step by step first, as parse this dictionary, get this array, and again parse each of the items within this array, dictionary arrays, and then get those values out, like the ID value and the value of the to do. So let's go back and do that. So we have the first step of deserialization happening. It's converting that to to-dos dictionary. Let's call it to-dos dictionary. To-dos dictionary will have to-dos. So after deserialization, it should get me the to-dos array. So let me just do that. If let to-dos array is accessed through this dictionary, so maybe I can call it ns array. Let me print that and see whether we will get it as the to-dos array. Let's rerun. So you can see that something has got printed and is actually printing that array of dictionaries here, comma separated. So the next step we can do is fetch all those to-dos arrays. So to-do dictionary, this is actually a to-do item dictionary that we are looping through. So it's of type, let's convert it to again it's a dictionary, so we can call it string. So within an array we have an array of dictionaries. So something wrong still. Maybe you can call it any type. That looks like fixed. So closure expression is unused. Okay, let's do that. That looks to be some other issue here. So item dictionary. We have the ID as one param. Next one as the value. Hope this does not give any build error. Still has some issues. So let's go ahead and check what's going wrong. Okay. So at multi-level, we did the first deserialization, got the dictionary, and then arrived at the array by passing the key to that array. And again, we looped through each and every item to get the individual dictionary items. And then using the keys, we are getting the values here. So let's again run and see whether it prints it fine. So ideally it should give it as an optional, yeah. So you can see that it's printing it fine, but those are not still not cast to its particular type yet. It's still nullable type. So let's do that now. Let ID is equal to item dictionary. So this should downcast it to that its type. So that's the value, and can get rid of that. So we know that the value is coming back through these dictionary values, ID and value. So all that now we need to do is use it to insert into the database. So all you need to do is, you already have the code here. It's where you are adding a to-do item. So that let's use that creator update insert call here. And instead of this, we'll pass the value. So because we are auto incrementing based on the item which is received, we will not use this ID. So let's, for the sake of making sure that the value is received correctly, ID is just printed value is equal to value, so that values are printed, and we are passing this to the creator update. So what will happen right now is, once the value is received, should still type any. Okay, this should be cast as int and string, because on the server side these values are int. If you look at it, the response is of type integer and the value is string. So we have to correctly cast it to the particular types here. So let's build it once more. It's all look fine now. Let's change one more thing in the creator update. We should make sure that the new values are coming, which are coming should not be duplicated. So let's add a check here. So let's call it is empty. So we'll do realm dot objects to do item dot self dot let's have a filter, and I need to check for the value. Let's also check for lowercase, and it should match my to do item value dot lowercase. So if these two are equal, then I'll check whether it's empty. If there is any value, then is empty will be false. So is empty. If it's not empty, I'll just return and not insert that item. So that check is added now. Let's run and see whether we receive it and the value will get inserted to the DB. So you can see that the value is received from the API. Values like cleaning utensil, clean card, pay credit card, all that is being received from the API, and that gets inserted, that also got inserted to the DB. So if you look at it step by step, call the function, it returns the data, we deserialized it, and we loop through. It's a tedious process of deserializing, and the value received is sent to the database. And as you know that we have already written an observable where the initial the update and insertions will get called, where it will insert the values to the DB. So you can see that it's getting inserted to the view model. So this step was to insert it into the realm notified, and you are receiving the values here, the notifications, and you're just populating the insertions values using the realm result and then loading your view model using RxSwift. This whole thing is happening. So this is intact. We have the earlier code in place, just that we have included a networking call here, which is working fine now. Now let's get rid of this JSON deserialization tedious way of doing it, using an easier way, which I normally prefer, using SwiftyJSON. So it's a easier serializer where instead of this tedious call, we just need to call the provided wrapper for JSON deserialization. Just pass the data and you can then start using their functions directly to get the values. So for including that, all you need to do is to include the pod SwiftyJSON. Go to your pod, include that, stop this, and install SwiftyJSON. So that's included now. Let's do a clean build. So once it's built, you will be able to include the input. Taking a little while. This is where Swift has to improve. Compilation time is pretty slow, and it can become a nightmare if types are not set correctly, or if some typecasting is missed somewhere. Those are things which are still under optimization within Swift. So this is one of the nightmares of building when the size of the project increases. It takes a lot of time to compile, and if you are stuck in a older machine, then you're gonna have a nightmare there. So I think I'm almost done. Still going on. So you can avoid this by not doing a clean and rebuild all the time. Just because I had included a new pod file, I had to do it. Otherwise, it's not required to actually do it. So my build is almost done. Looks like. Yeah. So that succeeded. Let me import SwiftyJSON now. Yeah, that's available right now. So all I need to do is to replace this piece of code where the deserialization is happening. Let's comment it out, and let's include to-dos dictionary. Same approach, easier. Like we just need to do a JSON and then pass the data. That's it. So this is overall removing all these, and we don't need to cast it to anything. And then to use it, we'll have to, maybe you can do the same stuff there as well. Like you get the to-dos array. So we have the to-dos dictionary. All you need to do is call the get the values, to-dos, and then do a do an array, because we are expecting an array. So there are two ways of doing it. We have array, which is nullable, and you can directly cast if you're confident that you're getting this well. Let me do this nullable way right now, then get the values, do the same stuff. Okay, so to-dos array I'm looping through. Instead of this part where I get the dictionary, I can just do dictionary. I don't need to do any cast. So those are abstracted by this library, which is in a way good. So we have removed some of the code. Let's delete the app and run again. Let's see if we need a fresh install again, because Realm will retain those data which was earlier available. So we will not be able to see the result. So let's see. We have the to-dos data received JSON, SwiftyJSON will convert into that corresponding dictionaries, and using to-dos call the array, you will get the arrays. Loop through that, you get the dictionary, and using the dictionary you can pass the ID and the value, get the values. Let's run it. So you can see it's working as expected with a little more cleaner code, and that's pretty much for this tutorial where we venture into a little bit of networking using get. But let's get into something more complex in the coming tutorials, where we will include post and all those delete requests using Alamofire. There are lots of things you can do with Alamofire. We'll cover all that in the coming tutorials. Plus, we'll also include RX Swift usage when you need to respond back to the calling layer. So that's also interesting. So look forward for some more fun in the future. Until then, goodbye.